With this video, we're going to see how we can set up an ICE table. How can we work out the equilibrium concentrations within a reaction system? So remember, with this reaction system, we have our two reactants, iron 3+ and thiocyanate. They're going to react to form iron thiocyanate as a product, and they're going to reach some sort of equilibrium with each other. So we want to start off, initially we know what the concentrations of our reactants are going to be. We can just use simple dilution calculations to figure out what those initial concentrations will be within our reaction system. And also initially, if we were to sort of freeze things at time 0, then effectively we wouldn't have made any product yet. So there won't be any iron thiocyanate present initially. Then the system goes through some sort of change. We consume some of our reactants and we form some product. So then we can say at equilibrium then, we can use those initial concentrations of our reactants minus that change, that amount of concentration of our reactants that's being consumed, and we'll know how much of the iron thiocyanate we've created in our reaction system. So then, to work out our equilibrium constant, our K value, remember we're working out the ratio, effectively, of our products to reactants at equilibrium. So then, if we think of that in terms of algebra, we've got our X term there, divided by our A minus X term, times B minus X terms. So here we have an example of a calculation for our ICE table. We've got our initial concentrations there of our two reactants. Remember, initially we don't have any of our product yet. Then the system goes through a change. So we know that we are making some of our iron thiocyanate in this reaction system, which means we must be consuming that amount of our reactants within our reaction. So then at equilibrium, then we can come up with equilibrium concentrations for all three of the components that are now present at equilibrium within this reaction system. And so we're just taking the ratio of our products to reactants then to be able to work out our equilibrium constant for this particular reaction system. And we're getting a value of 132 when you do the actual calculation. So what that value is telling you, it's a value that is much greater than 1. So that's telling you that this is a heavily product-favored equilibrium system.